This video is all about the mysterious dark matter. Why is it mysterious? What do scientists use it for? And most importantly, is dark matter a particle? The great bulk of matter in the cosmos is made up of dark matter, a mystery, non-luminous element. Even though dark matter's gravitational effects have been observed for decades, scientists are still mystified as to its true nature. Despite our lack of knowledge, scientists do have overwhelming indirect evidence for dark matter. For instance, scientists use dark matter to explain how galaxies rotate and how the large-scale structure of the universe forms and evolves. In 1933, Fritz Zwicky of the California Institute of Technology invented the phrase dark matter to describe the unseen substance that must dominate one aspect of the universe, the Coma Galaxy Cluster. The galaxies in the Coma Cluster were moving too swiftly for their apparent mass, and dark matter was a possible explanation. Vera Rubin of the Carnegie Institution discovered evidence for dark matter in her galaxy rotation study in the 1970s. However, the nature of dark matter is still unknown. Telescope surveys have never detected enough small, compact objects to account for this massive amount of material. According to most modern-day astronomers, dark matter is likely composed of subatomic particles with properties that differ from those of protons and neutrons, namely non-baryonic matter. A weakly interacting massive particle, or WIMP, is the leading candidate for dark matter. The standard model of particle physics, which describes almost all particles and forces, does not include these hypothetical entities. WIMPs would resemble the ghostly neutrino, except that they would be 10 to 100 times heavier than a proton. But their weak interactions with ordinary matter make them difficult to detect. The exact mass of neutrinos is unknown, but they are much lighter than electrons. WIMPs, like neutrinos, would interact with only two of the universe's four fundamental forces: gravity and the weak nuclear force, which facilitates the decay of radioactive atomic nuclei. These dark matter particles would be electrically neutral, meaning they would not interact with electromagnetism, which is the basis of light, and hence would stay undetectable. In an attempt to detect WIMPs, physicists have built massive detectors and buried them deep underground to protect them from cosmic rays. But no experiment has turned up evidence for them yet. In recent years, this failure has caused some people in this field to worry if they've embarked on a fruitless particle hunt. According to the proceedings of the National Academy of Science, some scientists are turning their focus to a novel dark matter candidate known as the Axion, which would be a millionth or possibly a billionth the mass of an electron. Researchers are particularly interested in these hypothetical particles because they may solve another physics puzzle by interacting with neutrons and explaining why they can feel magnetic fields but not electric ones. Their behavior does not change when their electric charges are switched or when they are turned upside down. The standard model is perfectly okay with this, but researchers were concerned, so they devised a theory to explain this odd rigidity. As an aftermath, the explanation also proposed that the universe could be full of new hypothetical particles known as axions. The sterile neutrinos are another candidate. After being left in the dust, the particle has roared back into the race as a dark matter candidate. It is a hypothetical new type of neutrino. These ubiquitous particles currently come in three kinds and are almost oblivious to matter, passing through our bodies and everything else in the hundreds of billions every second. But while everyday neutrinos will occasionally interact with matter via the weak nuclear force, the sterile neutrino would only interact with ordinary matter through gravity. Even if sterile neutrinos are real, their mass and number are less likely to be adequate to make up the majority of dark matter. However, just as there are 3 types of ordinary neutrinos, there may be different types of sterile neutrinos with various masses. Furthermore, neutrinos may not be the only type of particle that has a sterile counterpart. The notion that there isn't just one answer to dark matter expands the field even more. It may be a mix of several types of particles or objects, or it could be a complete black sector of dark matter particles, like a mirror universe version of the Standard Model. If you liked this video, please consider subscribing and click the notification bell so you don't miss any upcoming videos.